Hello everyone and welcome. In this episode, we will take a close look at Istio's Ambient Service Mesh. So this is a service mesh that doesn't use sidecars. Please note that at the time of recording this video, this technology was in preview. We'll start off by defining what a service mesh is. This is to ensure that we are all on the same page. Then we'll take a look at the current architecture of Istio Service Mesh. This architecture uses sidecars. And then we'll take a look at the preview version of the Ambient Service Mesh that doesn't use sidecars, and we'll take a look at what the difference is and how things will change when this version will be released. For the demo, first we will walk through the process of installing the service mesh in our cluster. And again, please note that this was the process during the preview, and things may change when it goes to production. And then we'll take the Ambient Service Mesh for a test drive and take a look at its new features. And finally, we'll do a comparison between Istio's Ambient Service Mesh and Cilium's new service mesh, which is still in beta. I did a technology review of Cilium's service mesh recently. You can view that. I put a link in this video. Hope you can join me. A service mesh is a dedicated infrastructure layer that you can add to your applications. It allows you to transparently add capabilities like observability, traffic management, and security without adding them to your own code. So here's a picture of what the service mesh is. So we have application A that wants to talk to application B. And these services, as we mentioned, observability, security, traffic management, and resiliency, these are all provided by this magical layer called a service mesh. So in this episode, we're going to talk about Istio's new Ambient Service Mesh. Let's quickly go through the process of installing Istio in the current version and how it actually works. So we can install Istio by installing the command line called istioctl, and then we can run command istioctl install -- set profile. And then the profile basically says what features of Istio we want to install. There are various versions or features that it can be installed. And then when you say demo, it installs everything. So this is good for learning purposes. So in production, probably may not be a good idea. We need to decide what features of Istio you need. But in this case, let's say we say demo. And once that is done, it will install what is known as Istio control plane, also Istio-D. This is a process, and it has various components such as Pilot, Citadel, and Galley. Pilot provides service discovery for the Envoy sidecar that we'll be talking about shortly. Citadel provides security, and this provides MTLS authentication and encryption facility. And Galley provides integration between Istio and other services, systems such as Kubernetes. And in order to leverage Istio for our application, we need to create a label for whatever namespace that we want Istio to control. And in this case, I want to use the default namespace, so kubectl label namespace. So we need to create a label called istio-injection equal to enable. And once we do that, the label is created, and now from here onwards, this will be under control of Istio. So let's say we want to install an application. Let's start with the UI part of the application. We install the UI, and then Istio will automatically inject an Envoy proxy. It will also assign a certificate for the ID that is associated with this pod. And Envoy provides services such as load balancing, TLS termination. So the HTTP traffic, when it enters here, it is intercepted by the proxy, and then it turns into HTTPS. We'll talk about that in a second. It also provides HTTP and gRPC proxies. It provides circuit breakers and health checks. Also, stage rollout. Let's say you have V1 and V2 of your application, and you want to say 80% of traffic to go to V1 and 20% to V2 of the application. We can do that through Istio and the Envoy proxy. It also, we can do fault injection, and also provides a lot of metrics. Also, the Envoy proxy enforces all the network and security policies that we create. Now let's say we create a service for our application. It goes through the same process. It injects an Envoy proxy and assigns it a certificate. And now let's say service one or application A or UI wants to talk to its service over here. The first thing that Istio will check, or Envoy will check, to ensure that this is actually allowed. So there might be some restriction that will not allow this application to talk to this application. So Envoy proxy will check with Istio control plane to ensure that the traffic is allowed. If it's allowed, then it starts a handshake between these two, between this proxy and this proxy. And then certificates are exchanged to ensure that they are who they claim to be. And if that's the case, if everything's successful, then these two applications can talk to each other again. The HTTP enters into the communication from this pod here, or this container, then enters into the proxy here, and then that will be turned into HTTPS, so it's secure HTTP. It's transmitted over the wire to the other side. And conversely, when the results is ready to be sent back through the same process, the handshake occurs, a TLS handshake, and then the result is sent back to the requester. So it's basically a quick overview of how currently with the sidecar model, how Istio works. Now let's take a quick look at overview of Istio Ambient Service Mesh. So first, the question might be asking, why do we need a new version of Service Mesh? So the current version of Istio is sidecar-based. Basically, it uses sidecar, as we saw earlier. It injects a sidecar in every service that you deploy, or application that you deploy into Kubernetes. So inside, when you deploy a container or a pod, inside that pod contains the service that you are deploying, and then Istio also injects another container, which is the Envoy proxy that we talked about earlier. And if you have a few services in production, it may not be a big deal. But if there are hundreds or thousands of services hosted inside your Kubernetes environment, then that becomes a huge overhead, managing all those new proxies that are injected every time that you deploy an application, and managing those certificates, it becomes a nightmare in terms of performance. And that's why, and the Istio team is looking at a model of service mesh which doesn't use sidecars, a sidecar-less model of providing service mesh functionalities. As we saw, Istio provides these services such as MTLS, authentication and encryption. It also enforces security policies and network policies. It provides load balancing, health checks, stage rollout, and so on, the stuff that we talked about earlier. Now, in the new version of Istio that they're working on, these four features are actually split into two different components. One is called secure overlay, or this is basically L4. You can think of it as L4, which is really low level, at the CNI level, and L7, so layer also. So at the L4, when you enable Istio for a namespace, these are the services that you get immediately from Istio, and those are traffic management at the TCP level. So you get TCP routing. For security, we get MTLS tunneling and simple authorization. And for observability, we get TCP metric and logging. So if you don't really need any of L7 processing and you're happy with this, then you can go use this without incurring the overhead of L7 processing. So in the situation that you also need L7 processing, you can then opt in. So in the previous version, these features, all these features are provided. If you want it or not, really, you have no choice. The Envoy proxy provides all of that for you. And sometimes you don't really need, you have applications that don't need any of the L7 processing, you're happy with this, then you don't need to enable this. However, if you need to enable L7 processing, and by the way, L7 processing really is a lot more expensive in terms of CPU and memory than L4. However, if you need those, such as traffic management, and these are the services that you get through for traffic management: HTTP routing, load balancing, circuit breaking, timeout, fault injection, etc. And for security, there's a lot of really rich authorization policies that you can apply, and also network policies. And for observability, we get HTTP metrics, access logging, and tracing. Let's take a closer look at Istio Ambient Service Mesh's architecture. So just keep in mind that this was recorded early March 2023, and at the time of recording, the Ambient Service Mesh was in preview mode. So it wasn't even a beta version. So the architecture, this reflects the architecture at the time. It may change over time, so keep that in mind. So suppose we already have a cluster set up and we have some application running. In this case, we have in our default namespace, we have our UI on this side and the service associated with that UI on the other side on a different node. Now we want to introduce the Ambient Service Mesh and take advantage of its feature. So the first thing that we need to do is we need to actually deploy the Ambient Mesh. We'll go through that in more detail during the demo, but this is the command that we need to do. istio-ctl install --set port files is equal to ambient. So this is kind of signifies that we are going to use the ambient version. After that is submitted to the control plane, to the API server, then Istio control plane will be created. So will be the namespace, which is Istio system. So these are really the same process as before. Nothing really changed here. So what is changed here is now it will also deploy additional components such as ztunnel. So these are all installed as pods. So Z stands for Zero Trust Tunnel. So basically it creates, when the communication needed from between this two nodes, like this talking to this pod talking to the other pod, an overlay network will be set up between these two. So ztunnel will be responsible for managing that and creating a secure overlay network, and also setting up the handshake, the TSL handshake. So note that in this case, there is no Envoy proxy to manage that. So ztunnel takes assumes that responsibility of setting up the TSL handshake and also setting up a tunnel. So the difference here is ztunnel does not provide any HTTPS termination like the Envoy. Once this the tunnel is set up that the whole tunnel will be secure. So all the communication will be securely passed between from one side to the other. It will also install ingress component or ingress pods that will be managing the ingress as needed, and also installs the CNI. So because this Z tunnel and everything related to that is in lower level, lower than L7, so Istio will actually manage its own CNI in order to make that overlay network happen, because that is again lower than L7, so it needs to manage its own CNI. So let's say now we want to, our default namespace to take advantage of the service ambient service mesh. So again, as usual, we need to label that, and the label that we need to create, it's called istio.io/dataplane-mode equal to ambient. So once that's done, then the namespace will be created. The label will be created for our default namespace, and also Istio will be issuing the certificates, because we already have a service on this side and a service on this side. Then appropriate certificates for TSL will be installed. So all the applications on this side will be managed by this tunnel, and all the applications on this side will be managed by this tunnel, by this Z tunnel over here. So assume that the application, the UI, wants to talk to the service. So the request is sent, and then it's intercepted by Z tunnel. And Z tunnel basically looks at the policies and see if there are any L4 policies created for this communication, and if it violates it or not. If not, then it will set up secure HTTP tunnel with the other side, with the Z tunnel on the other side, and then performs the handshake. So basically certificates between these two will be, which this one represent this and this represent this, are exchanged to ensure that this certificate really belongs to this, or the caller is who is claiming to be. If everything is good, then it will continue. The communication will be sent through the overlay network to destination, which is this pod over here. And again, in reverse, when the results are ready, goes through the same process of tunnel, and the results are sent back to the other side. So at this point, we are not really using we don't need any L7 at this point, and so there is no additional proxy created, and life is good. But sometimes you want to take advantage of the L7 functionality and features, and in this case, then we need to make a request to the API server, and we need to create a special gateway called Istio Mesh, and the type has to be, the class name has to be gateway class name. You need to specify Istio Mesh, and then we select the name for it, and then this will be the service account that this is running on. So once we apply this, then Istio will deploy what is known as waypoint proxy. This is basically a version of Envoy that we've seen before in the previous version of Istio, and it's called waypoint. And this will be managing all the L7 traffic between that are destined for this service over here. As we create more services and we need to manage those, additional waypoint will need to be created. So you already see the benefit of this architecture. We are not injecting any pod, any proxy inside the pod as before, and now we have a now clear and clean distinction between the L4 and L7. And then in this point, let's say this UI wants to make a call to its service on the other side. And the service will be intercepted because that will be managed by this waypoint proxy here. And it will check to see if there are any authorization policy, and every policy that might apply to this. Does it need to do a rollout, stage rollout, like percentage rollout, or you need to retry, or so if any of this apply, then this proxy will be responsible for apply those, and then the request again sends through the tunnel to the other side. So this is basically how the communication happens. And now that we have both L4 and L7 components in the picture. Next, we are going to take a look at how we install, in the demo, we will take a look at how we install the service mesh, ambient service mesh, and what the requirements are. At the time of recording this video, the only environment that ambient service mesh was supported was installed inside Kind. So if you're not familiar with Kind, is an environment, is basically a software that allows you to quickly set up a Kubernetes environment. So it does all the heavy lifting for you. It's really great for learning and basically testing. This is not a good environment for your production, but it's just meant for during the development. And it's supported on Windows, Mac, and Linux. The instruction that I provided as part of the download is to set up the Kind environment in a Linux environment, a Linux VM. The first thing that we need to do is we need to install Docker. So Kind does not support container D, so has to be Docker. So once you install the Docker, which is this part here, then you're ready to install Kind. Very easy. You just go to this URL, you download that, and then you basically copy it to a location which is on the path, such as /user/local/bin. And then you need to create the configuration, a Kind configuration. You specify, so you basically create an environment variable called Kind, config equal to, and this is the content. The Kind is cluster, you create a cluster. And the API version, this is the version at the time of recording. And then you specify a name for it. And then you basically, that becomes your cluster. And then cluster name, and then you have, you need to specify the roles, so the control plane. So obviously, just one, probably during the development, one control plane would be enough. And then the name, the number of worker role that you need to create. Here I created 2 worker nodes. So in this configuration, it will create a control plane, single control plane, and also 2 worker nodes. And then we feed that variable into this Kind create cluster -- config equal to, and then the content of that environment variable. And once if everything goes well, when we can test it on line 30, kubectl cluster info -- content Kind -ambient. When you run it, it should get something like this. It gives you the address of the API server. So this is really a quick way of setting up Kind, very easy to do. So once you set up the Kind environment, which creates the Kubernetes cluster for you, then you're ready to set up Istio. And on line 1, this is where you get the latest version of Istio. And then on line 3, you need to also get the ambient component, which is an add-on to it. So this is where you get it. That was at the time of recording this. So if you try it later on, make sure that you check the installation documentation to make sure you get the latest version of the ambient preview or beta at the time of your installation. So, and then we unzipped what we just downloaded and copied inside the version of Istio that we downloaded at the time of recording. It was Istio 1.17.1. So when you, on line 1, when you download that, it will also create a folder for you. And that was at the time of recording, the version was 1.17.1. And then you assign ownership to yourself, and then you assign execution and read and execution permission to the ICO-CTL, and then you copy that ICO-CTL that comes with the new ICO-CTL that comes with the ambient component. You copy it into the user local /bin, and finally on line 12, you are ready to set up Istio with ambient features. So Istio-CTL install --set profile is equal to ambient. Let's go ahead and run that. And we say yes. And it will take a couple of minutes in order for installation to complete. So the installation completed now, and these are the components that was installed we talked about earlier. Now on line 14, we can take a look at all the components that was deployed as part of this. Look at the pod. So kubectl get pod, and the namespace is istio.system. Let's go ahead and run that. As you can see, the component that we talked about, the CNI, also the Z-tunnel, and also the ingress. Okay, so now we are ready to do some testing. So let's go over the demo that we are going to do. First, recall that we just enabled the ambient service mesh for the cluster, and these are some of the components that are deployed as part of that operation. So in our cluster, we have two worker nodes, node 1 and node 2. What we're going to do is we're going to deploy a sample application called book application. Basically, this is a fictitious online bookstore. And then it has a number of services such as product page. So this is the HTML page where users can take a look at what books are available. Then there's a details page, the ratings that the books will get, and also reviewers can write reviews. So this is a very simple application that's provided by the Istio team. We also will deploy two client application, one called Sleep and the other one non-sleep. So basically, we are going to use this as the client to sit in for our client, as our clients that will be consuming these services. And each service has its own service account, and they are all mentioned here. And so those become important when we talk about policies. And then we also deploy a gateway, and this gateway will allow the clients that are outside our cluster to come in through a node port. So a random node port, in this case 32040, it could be any number, in that range will be created. So again, that will enable our people coming from outside the cluster to be able to consume our application. Next, we will create a new label for our namespace, default namespace called istio.io/dataplane-mode equal to ambient. So the net result is then the default namespace will be under the control of the ambient service mesh. And it will also, Istio will be deploying certificates to this to the Z-tunnel for each one of those services. So from here on, all the communication that goes from this node to the other node will go through the tunnel, the Z-tunnel. When we get here, the tunnel, for instance, let's say the sleep service wants to call the product page or detailed page, then this will, the Z-tunnels on each side will do an MTLS handshake, basically validate certificates that our certificates are valid, and the user, the service in this case, the sleep is it's a service side is claiming to be, and conversely, on the other side, if this is calling the detailed page, then the details will, the tunnel, Z-tunnel on this side will use its certificate to again send it over to this Z-tunnel to validate that indeed this is coming from the details page, and there's no spoofing is going on. And then we start looking at some L4 policies. The first one that we're going to create is we are going to explicitly allow sleep service account and Istio ingress service, that is this component here and this the gateway here, the service account that are associated with this are allowed to call into the product page. So you'll be able to call into this one. So this one, not sleep, will not be able to connect to or call the product page, and we will validate that. Next, we'll concentrate on L7 authorization policy. And the first one that we're going to look at or create a policy for is the product page. And recall that we need to deploy a waypoint proxy. So all the policies that are created will be enforced by the waypoint proxy. So we'll create that, and then we update our policy that we had earlier. So earlier we had a policy that allowed the service account associated with sleep and gateway to call into a product page. We will enhance that. We will add some L7 specific policies. In this case, we'll only allow get operation. So you have get, put, update, and so on. So those are the HTTP word. We'll only allow the get operation to happen when either when the call is come from either here or the gateway, which means that the external client is calling into this, will be allowed only the get operation on the product page. And then we concentrate and we create another policy, this time for review. And again, we need to create another waypoint proxy specific for reviews. And in that, we are going to create a policy which will, when the traffic arrives here, before going through the tunnel on the other side, this will mitigate the call and will send 90% of traffic to reviews V1 and 10% to reviews V2. So this is how this is a demo that we're going to do next. We are back in Visual Studio Code to go through the demo. So the first thing that we want to do is capture where Istio is deployed, because one of the sample applications, the book info, is installed inside that directory. Let's go ahead and capture that. You're going to use that information now to deploy the book info, which is in the book info.yaml, which is saved under the Istio directory under samples. So let's go ahead and run that. And that will install all the services that are associated with the book info. We also have two clients called sleep and not sleep that we'll be using for testing purposes. And those two are coming from GitHub, so those are now deployed. We're also going to create a gateway, an ingress gateway, so that our external client will be able to access the application from outside the cluster. So let's go through the code here. And that will consist of two sections in this YAML. One will create a gateway. And basically, that gateway, we have to say what port we'll be listening on. So this is port 80 internal to the cluster. But when the client comes from outside the cluster, that will be a node port that will be created. We also need to specify the protocol for that, HTTP. And then the next section, we will be creating a virtual service, which essentially will when the call's coming into that gateway, it will parse the URL and looks for the destination. And then these are the valid destination that are supported for this service, slash product page, slash static, slash login, slash logout, and then slash API v1 product. So if these are, it's one of those, then the call will be forwarded to the service, the product page service that is running on port 9080. Okay, let's go ahead now and deploy that gateway on line 8. You see that the gateway was created. Now we need to capture the ingress port number, that is node port that was created when we created that gateway. We need to capture that so that the client will be able to call in. We also need the node that the gateway was installed on line 12. We're going to capture that also. And now we can construct our gateway URL again for the client that are coming from outside. Would be the URL would be the combination of the host, the ingress host, and the port number. So go ahead and do that, get that, and then we echo it out. So this is the IP address and the port number of our service, the node port that the client will be needing to call the service from outside. And line 19, we're going to capture the name of the pod that hosts the product page. And we are going also on line 22 to kind of for sanity check. We want to make sure that there is no container is injected inside that. So we're going to take a look at the pod, and we're going to look at the JSON path. Inside that, we are looking for the containers, the list of containers that are part of that that pod. There should be only one container. And as you can see, it is only container page. So there is no injection going on. So then let's go ahead and now, as part of this, for monitoring the services, I'm also monitoring one of the zTunnel logs. So this is one of the zTunnels that are installed when we deployed the Istio Service Mesh, Ambient Service Mesh. So right now there shouldn't be any traffic coming through this. You saw some traffic that is normal traffic that Istio is sending, communicating with the zTunnel. However, when we run our application, there shouldn't be, before enabling the ambient mesh for default namespace, there shouldn't be any traffic coming through that, and we can verify that. And that's what we're going to do on line 27, kubectl exec deploy /sleep. So basically, we are going to, from the sleep pod, we're going to exec into that and then curl into the product page using the gateway. So let's go ahead and run that, and we'll see that we get the result back. I'm only showing the one line here. We don't need to see the whole HTML page, basically to just make sure that everything works. So we go back now to the zTunnel, and there's nothing coming here because we haven't enabled the ambient mesh yet. And we do more tests. We're going to now call the product page again, but now this time directly. So in the first instance, we use the sleep pod to basically go outside and call the port, and then the port, the port that node port that is listening on, the service listening on from outside, and then they forward the call to product page, which is listening on 9080. However, because that sleep is also is installed inside the cluster, we can call that directly, and that's what we're going to do. HTTP and then product page and product and port number 9080. Let's go ahead and call that, and that would be, again, we get the same result. And we're going to call the product page again And this time we're going to call it from the not sleep. So let's go ahead and do that. We see, we get the same result. If we go back to the tunnel, still there's nothing coming in because you haven't still enabled anything yet. Okay, at this point now we are going to create a label called istio.io/dataplane, a dash mode equal to ambient, as we saw in the presentation part. This will enable service mesh for our default namespace, and we can verify that the label was created correctly on line 36. kubectl describe ns default. Let's go and take a look. And if you look at under labels, we'll see that the label was created. Now let's do some testing and see how the ztunnel look now. So kubectl exec, we do the exact same test. We're going to call the product page on port 9080, and we'll see that we get the result back because we don't have any policy yet. But if we look at under the ztunnel, we see that the traffic is coming in. Again, ignore these two. Those are communication that is going on between Istio and ztunnel, but this is the one we're looking for. So we see that our call is now went through the ztunnel. Let's do another test. This time we're going to again call the same service. We're going to call it from a no sleep pod. Let's go ahead and do that. We get again exact same result. If we go back here, and we'll see now that we have a new line here, entry, and this is coming from the second. So we'll see that now the communication is going through the tunnel and it's secure. So let's go ahead and create our first policy. And the first policy is an L4 or layer 4 policy. And basically it says that explicitly allow sleep service account and Istio ingress service account to be able to call the product page service. So let's go through the code here. So the kind is authorization policy. We select a name for it. We call it product page viewer. And then under what is allowed. So we first of all look at the labels. What interests us is the product page, so that what is applied to the product page. And under allow, we have a rule which says from source. So basically what it all means is if the source is coming from the service that has the service accounts either sleep or service or ingress gateway service account, those are allowed to call into the product page. So one, the ingress again would be for the client from outside, and the other one would be for the client that's coming from inside the cluster. So let's go ahead and apply this. So that's created. So let's do some testing now. The first one, we are going to call the product page from outside. This is from coming through the gateway, and we are calling it from the client, which is the sleep. So let's go ahead and do that. And this is allowed because the service account associated with that is allowed to call into the product page. We do the same thing. We do the exact same thing from the sleep client again, and this time we're not going through the ingress. We go call the service directly through the port number 9080 and the product page. Let's go ahead and run that, and we'll see that this one also succeeds. However, the last one, we are going to call the service from not sleep. So let's go ahead and call that and see if that's allowed. We'll see that an exception is thrown because that service account is not allowed to call into the product page. So when we take a look at the Z tunnel, we'll see that the last entry says RBAC access denied, and because that again, Istio is monitoring that, and Z tunnel will not allow if traffic is if the policy is violated. Let's go ahead and clear that. Okay, let's go ahead now and do some L7 policy. And before that, let's go ahead and take a look at all the pods that are in the current default namespace. And this is the name, these are the pods that are already deployed as part of our application. And the reason why I'm showing this is when we go through the process of creating L7 policies, we need to also deploy proxy, the waypoint proxy, and those will be created in the default namespace. Kind of, we will verify and compare to the list that we have here. Okay, so the next thing that we're going to do, we're going to create an L7 policy, which basically states that we modify the policy that we created, the L4 policy that we created earlier. We're going to modify that, and we keep the same restriction. Basically, those two service accounts from the sleep and from the gateway are allowed to call into the product page, but we also modify that. We add a clause that it says only the get operation, HTTP get, is allowed. But before doing that, first we need to create a proxy, a waypoint proxy, and this is the code to do that. Let's go through the code. The kind would be gateway, the name, select the name for it, the product page, and then this basically specifies the service account for the service that we are going to deploy it for. So in this case would be the book info product page, because that's associated with our product page. And we need to specify this. This is mandatory, and the specs gateway class name is Istio Mesh. So we need to specify that when you create this. So let's go ahead and run that. We see that it was created. Now let's do another look of our pods that are created in the default namespace. Let's go ahead and run that. We see that we have a new one called book info product dash waypoint dash proxy. So this is kind of the proof that we now have a proxy called waypoint that is created as a pod. Let's go ahead and clear that. And now we proceed to actually now, we also can, if you want to know more information about the gateway that was created, you can do kubectl gateway product page -o YAML. We get a lot more information about how the proxy was created. And most importantly, we'll see that the status is ready. So we'll see that it was successfully created. Now we are going to, having that waypoint proxy, we're going to now create a policy for our product page. Let's go through that. Again, we select a name for it, and the kind is, we use the same authorization policy as we had before. So nothing really changed here. This is we are basically leveraging the same policy that we created earlier for our L4. And the only thing we're going to add is we're going to add a to, and then the operation method get. We only allow get method. So we can add other operation that is needed, put, delete, and so on. But in this case, we are going to only add allow. So basically, the end result is only calls from that are coming from these two service accounts, which is from the sleep and the default gateway service accounts. And only those are allowed to do a get operation. So if they try to do something else, it should fail. So let's go ahead and apply that. Now let's do some testing. And on line 118, kubectl exec. So we're going to exec into the sleep again, and this time you're going to delete. We try to delete something. Let's see if it succeeds. And the answer is no. It says RBAC access denied because the policy does not allow delete. And then on line 120, kubectl exec deploy. And let's do the get operation from not sleep. And again, this shouldn't be allowed. We'll see that it fails because that service account is not allowed to call into the product page. And lastly, kubectl again exec into the sleep. And then we curl, we do http get product page 9080. Let's go ahead and do that. And this one finally succeeds because that is allowed. So because we are using L7 policies now, it also, the proxy, the waypoint, which is basically an envoy proxy, also generates a lot of logs and metrics. For instance, in this case, we want to know how many policies violated, access denied, like this 403. This is what we can do, is we can curl into this port, which is 15020. This is a default port number that reporting service basically listens on. And then we basically grab grep for 403. Let's go ahead and do that. And you'll see that these are all the instances that a policy was violated. So again, there's a lot more into that, and I've spent a lot of time in the other video. If you want to know more about reports, so refer to that Istio course. Okay, now we're going to do another policy. In this case, we are going to work with reviews. So first we need to create a waypoint proxy before applying any policies that are related to reviews. Let's go through that. Very similar to the other one. The only difference is we are looking at reviews. So this is related to reviews. Service, so this is the service account that's associated with the reviews. So let's go ahead and run this. So we created that proxy. Now let's take a look at our pods again. And we'll see now we have another pod. This is the waypoint proxy for the reviews. And again, for a sanity check. Okay. Now, in our last policy, we want to, when the traffic arrives for the reviews, we want to the proxy, the envoy or waypoint proxy, to send 90% of traffic to reviews V1. If you recall, we have two versions of reviews, V1 and V2, and we want to send 10% to V2. And these are the policy associated. This is how we created. This is a virtual service for that operation. Basically, this is the specify the destination and weight. So the weight for V1 is 90, and for the other one is 10. And the actual service destination is defined here. So looks at the labels. V1 is version V1. So the service that has labeled version V1 will be considered V1 here, and 90% of the traffic will be sent here, and similarly, this is for V2. There's also V3 here that we are not using, but this is basically how we define a service. So let's go ahead and run that, and then also we need to run the other one. And then now on line 151, we're going to execute this service. We're going to call the reviews a number of times, and then 100 times. We just want to verify that 10% 90% goes to V1, and 10% goes to V2. Let's go ahead and run that. Let's let it run for a while. And as you can see, majority of them are V1, and then we have a V2 here, V1, V2, V1, 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 and so on. So this is kind of an indication that the percentage is working correctly. So the last topic that I want to discuss in this video is to provide an overview comparison between Istio Service Mesh and Cilium Service Mesh. I recently covered Cilium Service Mesh. You can watch it by clicking on this notification on this corner up here. So let's take a look at overview of how Cilium Service Mesh works. So you probably know Cilium as a CNI provider, and that is true. And they are actually a great service CNI provider because their services are run as eBPF programs. So eBPF is a way for developers to extend the Linux kernel without actually recompiling the kernel itself. And the other advantage is, feature actually, is that many of the features that we know as service mesh, such as traffic management, security, and observability, and traffic management up to L4, they are implemented as eBPF programs. So when you deploy Cilium Service Mesh, it will also deploy an Envoy proxy per node. So each node will get its own Envoy proxy, and all the L7 traffic management and also enforcement will be done by that proxy on each node. So this is different than the way Istio works. So as we saw, we only deploy the waypoint proxy for a service when L7 features are needed. Otherwise, we don't deploy that. However, that's different from Cilium because those Cilium Envoy proxy will be deployed on each node, you want it or not. So there are plus and minuses to that approach. The plus is when you have a proxy running on each node, then the overhead becomes less because this will be managing all the traffic. In case of Istio, then you have to deploy many proxies because each service will get its own version of the proxy. However, on the flip side, if a hacker gets hacked into a node and get hold of the Envoy proxy on a node, then they can monitor the traffic on that node. So there are pluses and minuses to each approach. And through this Envoy proxies, then we get things such as load balancing, TLS termination, retries, and so on. So those are the features that we've seen before, and so you will get those features in Cilium as well. Now, when it comes to MTLS authentication and also encrypting traffic between nodes, Cilium takes a different approach. And this is not yet part of the product. This is kind of a vision that they have for the future. So what they're thinking is they want to allow you to bring in whatever identity and security management that you like into the Cilium environment. So the control plane, it's up to you which one to select, such as the selection such as SPIFFE or Cert Manager or even Istio. Use Istio CA for deploying certificate. So, and then when you deploy a service, then the CA authority will issue the certificate for each one of those services. And then those certificates will be used on behalf of each application for MTLS authentication and handshake to ensuring that these certificates are valid and also that they are who they claim to be. And then if you need encryption between between nodes, then you can use WireGuard, which is basically a VPN. So it provides a secure tunnel between the nodes. So this is a little bit different than Istio's approach. You can opt in if you want to. If you don't need encryption, then you don't need that because that provides some overhead. So if you only need authentication, then we can just use the CA authority to certificate to manage certificate and also the Cilium agent to provide the handshaking between them. So you don't really need, if you don't need the encryption, then you don't need to deploy WireGuard. So again, this is different from the approach that Istio takes. In Istio, the Istio handshake and the encryption between the nodes, they come together. You really have no choice. You can't opt out of any of them. So this is kind of, hopefully gives you an overview of where each product is going. And again, they're still in beta, so they're not their final products, and things may change in the future. And so this is, I think, is really fascinating space to watch. And as we have more competition, it's actually better for us users. And so we'll see which one works for us better. So I hope that you enjoyed this video. If so, give it a like and also share it with your friends and colleagues. Thank you.